right, so Dr. Irfan Akpan here. I've been really interested in a lot of the new talk on AI, and what I mean by that is, old school is 24, 25, if you think about it, and we're really over halfway through 2026, and things have changed so much from 2025 and 2024 that it's amazing. I wanted to touch on actually some more as far as coding and looking at how things work in that particular framework. And I think this is a very interesting video. I'm a really big fan of David Ondrej and a lot of his guests that he has on his channel. So let's take a look.
The agent go cook, there are decisions that it's going to make that you might not like.
If you can tell it a measurable output, the agent will move mountains for you.
You can tell the model how you want it done. And if you don't tell it how you want it done, okay, it might do it in a terrible way, but it also might figure out like a better way to do it that you never would have come up with.
This is Dexter, also known as Dex. He is the one who invented the term context engineering. And he's also known for creating a software factory where AI agents ran for 4 months straight without any human input. In this podcast, we talk about why benchmarks don't matter, his unique program design system, and why pull requests are dead. If you want to be in the top 1% of agentic engineers, watch until the end. This is the David Ondrej podcast. Enjoy. You had a thought on benchmarks not being an accurate way of representing agents' power. Can you tell more about that?
This is basically about the idea that like a lot of benchmarks are like one-off problems. They're quick, one shot, fix the tests, do all this stuff. And like, I don't know, I am not a machine learning expert, but like I was doing a bunch of research on this because I wanted to match my vibe understanding with like how this actually works in the real world.
So you let basically agents run by themselves. Give us the backstory.
So like Software Factory has been around since 1968, but like I like to think of like the 2022 Software Factory, right? Which is basically like right before AI, you had a team of humans and they would put stuff on a list of things to do. This was your Jira, your Linear, your state machine, your issue tracker. And someone would go build the thing. And then like eventually you would do a pull request and you do your CI/CD and all kinds of, we've automated a ton of stuff, but we still review the code by hand. If something is wrong, we loop it back to building the thing. Eventually goes into prod, hits our users, they complain about stuff, they ask for features, and then we go around the loop over and over again. And then eventually we put on monitoring so we can wake people up at 3 a.m. Because apparently we love to wake engineers up at 3 a.m. when things break. But this is your like Software Factory before AI. Basically, the first thing that happens after that is you replace like person builds the thing with agent builds the thing. I'm not going to get too much into like orchestration and harness and sandbox and model. Like you need all these things, but basically like every single thing that comes off your list, this is the ramp, the work OS, the Brex, they all have the Stripe minions. They all have their like system that does this. And this is the first thing you replace. And you probably leave most of this other stuff in here. And basically like now this part takes minutes or hours.
So now everything is starting with the agent. So you see the orchestration, the harness, the sandbox, the model. So everything is running. It's starting with the actual AI part of it, which adds the speed point.
And this part still takes hours or days. I guess like before we had agentic factories, we basically had like people noticed that like building stuff took hours or days and reviewing stuff took hours or days. And so we did this stuff to like get more leverage, which is basically like we'd sit in a freaking meeting and talk to other engineers about what we were going to do so that like instead of spending 6 hours reviewing it, maybe there's like a better chance that like, oh yeah, this is what we all talked about. The PR matches what we explained and there's like very little changes required. And so like we want to basically optimize, spend an hour up front to save hours in the review time, in the build time, make sure we're not building the wrong thing, etc. This part is now fast, but this part is still slow. And we bring in like agentic code review and it catches all the small stuff. And we let the agents like just poke at the app and test it with browser testing and stuff like this. And that makes this faster. But like, if you want to read like the code that matters or any of the code or all of the code, whatever it is, like this is still your bottleneck of like, how do you build trust that the thing that was built is going to work today? And
so humans are the bottleneck. So humans are what's slowing everything down.
It's not going to like slow you down in a month, right?
If you're, getting tens of thousands of lines, you cannot review that manually.
Yeah.
That is the bottleneck for sure.
So you do what you can to build trust. You say, okay, well, we threw Codex and Opus at it, and they both said like, they both found 10 things, and we fixed all 10 of those things. So now I have higher trust that this is going to be like, I'm not going to get a ton of complaints and feature requests, and I'm not going to like get woken up at 3 a.m. because something broke. And then we could do some stuff like routing.
But my question is, you still have AI testing and building trust with AI, which can make errors, but what is the error rate for humans? So there's still issues that come down the line with humans. So the question is, do we trust the error detection of humans? Which is better, human error detection or the AI error detection? I think many times we're talking in such a way that humans are perfect and will catch errors and we're infallible, when actually we will have some sort of errors as well.
And straight into the factory. So when the alarm goes off at 3 a.m., I don't wake up to an alert. I wake up to a pull request. And we can do the same thing with like user feature requests, right? Instead of like going through a support queue, we triage some of the support queue straight to the agent, and it just goes and fixes the bug. Have you done any of this yet?
Yeah, I'm implementing this as much as I can, to be fair. For example, for my current thing, Deep API, I have like GLM 5.2 review every single like uptime incident. So anything that's like suspicious or anything that it goes down before, I have to like read it and understand it or use AI to understand it. But now I just get like an AI report of like, oh, this is what's happening. It's actually the provider. We cannot do anything about it. Or like, oh yeah. This is caused by missing migration. Do this.
Yeah. They're like, oh, Anthropic is down right now. Like you just have to like tell your users and like, here's a draft of a message you can put out in your Discord channel or whatever. That's cool. Where are you running that? Is that running like in a cloud sandbox somewhere?
It's split between render.com and just cron jobs on Vercel and GitHub Actions.
Okay, so you have cron jobs on Vercel, and then like when incidents happen, you pull them in, and then render.com runs some little agent loop that does inference and then like sends it somewhere.
Yeah.
Cool.
Now launching your app is just step one. The moment some users show up, the question becomes, what are they clicking? Where do they drop off? What's breaking? And right now, that information is scattered. You have one tool for analytics, one for surveys, another one for error tracking. But with Posthawk, you get all of this in one clean platform. You can link all your data sources and query everything alongside your product data, so you can find real correlations and real patterns instead of just guessing. There's also session replay, so you can watch recordings of real user sessions to see where exactly they get stuck. But honestly, you don't even have to watch this yourself. Posthawk's new AI tool, Replay Vision, watches those recordings for you. It automatically spots any friction, and an agent opens up pull request with the exact fix. So all you have to do is just review it and merge it. That's the whole idea. Posthawk makes your product self-improving. And this is essential if you're building software in 2026. For example, most people have no idea how to monitor their AI inference costs, but Posthawk does all of this for you. It tracks the prompt, the response, the token cost, and the latency. Everything per user, so you can see which features are burning money, which agents are misbehaving, and which prompts are actually working. This is what you need to build a great product.
Introducing a revolutionary experience for developers.
You can try Posthawk for free by clicking the link in the description. Oh, and thank you, Posthawk, for sponsoring this video.
So this is like, when people talk about the full software factory, this is like getting towards like, how do we take ourselves out of the loop? If something can be just one-shotted by an agent, even if it's only like 30% of your work, only 30% of your incidents, that's huge. That's like, you're getting close to doubling your productivity, right? Because if you can automate 50% of your work, you can now ship twice as much. And so like, now the thing is like, cool, now our job is more just like, ask for features, evolve the platform, think about strategy, and then like how fast can you review the changes?
Yes.
Which gets us to this thing that I don't think works, which is the lights off factory, where we just say like, okay, we're just not gonna read the code. Like how can we build a system where we don't have to read the code, or we have to read as little code as possible? Do you still review your PRs that the agents write?
Not like all of them. If there's a small change, I just ship straight into production. Like one maybe controversial opinion, and again, like I have less experience than you, so like, I have to preface that, but like I have a good sense of like my prompt, right? If it's like a small front-end tweak, I know what the agent is going to do. Like I just have like over 1,000 of hours building with AI, probably over 100 hours with these new models. But like I just know like what type of things the agent is likely to fuck up and what I can trust with. If I'm not sure, again, I do the basics, right? Review it with the other frontier model and do more testing myself, stuff like that.
That makes sense. And basically the idea is like if you want to get out of code review, you end up investing into all these other things. You make it so the agent can test its changes live. Maybe it can even send you a little video when it's done building. This is like the Cursor sandbox agents do this. You make your agentic code review way better. You make your regression testing way better. Every time something fails, you go figure out what it was and you make sure that that particular failure mode never happens again. You make your CI/CD checks better and more robust. You add more different types of linters. You do complexity monitoring, all this stuff. And so now your job really is just like, how much stuff can you think of? How many features can you ask for? How many features can your users ask for? And like, you can actually run this thing where you don't ever read any code. I personally don't think this works. And this was like kind of my epiphany. And like, I mean, I think if you've used agents for a while, you kind of have this vibe of like, if you do this for like way too long,
you can like completely lose the touch of the code base, right? So then like maybe the part that like I would add is really spending time on the agent educating you. Like checking, like, is the human still in the charge? You know, like giving you some quizzes, giving you some like HTML visualizations and kind of slowing down on purpose when you start to lose the grip.
Yes, exactly.
Real quick, if you want Dexter's exact program design system that he uses, it's going to be available as the first link below the video. It's completely free. Go grab it now.
We even had a prototype feature that I didn't end up shipping, but we may bring back, which was like, while the agent is working on stuff, you can pull up the session and it'll quiz you on like, what is the current state of the code base and how does it work today? And then like, how does the new implementation work and what does it change? And you can like test your understanding with like multiple choice questions with different mermaid diagrams and stuff like this. Anyways, we did this for a while. And basically like the idea here is like, if you stop reading the code, you might, or you absolutely will eventually hit an issue that the agent can't solve. You're like, oh, this is broken, go fix it. Oh, this is broken, go fix it. And like you try all of your like most intense prompting and you get 3 of the smartest models together to do a council on it. And they just keep thinking it's something that it's not. And they keep shipping fixes that don't actually fix it. And so you have to go into the code base that you stopped reading 3 months ago and spend like days or weeks, like 1, like trudging through like sloppy code because you stopped reading it. And 2, like trying to figure out what is actually wrong. And this has happened to us at least once.
So this is another problem that I think someone needs to solve. And he's mentioning that if you're not looking at the code, not monitoring it, there will be a problem. And once that problem happens, you will have to jump into something you don't really know inside and out or know exactly how it works. And you're going to spend a lot more time working with it.
Or twice, which is why we kind of like threw out we did this in like July of 2025. We had this lights off factory where we're like really zooming out and not really looking at the code so much. We reviewed the plans and we did like collaboration on like the tickets and like what went into the to-do list, but we weren't reading the code. And then we hit a bug. Like 4 weeks, it was like, okay, our site was like, I mean, we were shipping a desktop app. So like the app was buggy. Users were pissed. We were miserable reading through a bunch of like slop code, trying to figure out what the hell happened. And it sucked. And I kind of had this thesis that like the odds of this happening to you if you stop reading the code are much higher than the odds of it not happening to you, or like that the models will get smart enough by the time it happens that they will be able to solve it.
Maybe I would challenge you on the wording, right? Like, is code the right word? Because like you can replace code by the logic. Like if you understand the underlying logic of your software and like, are we using a certain API schema, or like what's the difference between hashing and encryption? If you just understand these concepts, you don't necessarily need to look at the code per se. You need to know like the logic of like, okay, what does the first 5 minutes look like in the onboarding? What does it look like when someone tries to cancel? What does it look like when this API endpoint fires? Maybe I would challenge the word code and like replace that with logic, no?
Like know what the product is. I'll jump ahead to kind of like I'll go back to like why I think this is. We do a whole thing in like RL and how the cases work and how it's like kind of obvious that is how it happens. But we basically go through like 4 stages, and I can demo this in a little bit with our tool, but like you don't need any tool or any specific set of skills to do this. This is just like what I think is the right way to think about aligning with AI and kind of staying in the loop as much as possible. And the first one is like the product part. Like what user problem were we trying to solve? And like, if you can do it, how do we measure it, right? Because if you can put an experiment on your website and say like, okay, this is hard to use, the agent can try 3 different things and then it can check the data every day and decide which one works best. That's incredible. Huge. Now you're really getting on autopilot, right?
And this is something that the latest generation of agents is like doing way better. Like I noticed, with Fable and 5.6, so like I don't have to tell them to run tests. I just noticed like if they do something medium sized or large, they just try to do way more testing by themselves. So I think, yes, in certain areas, you still have to like think of ways to measure and track. But with the models getting better, they're doing this by themselves.
When you say testing, are you talking about like doing like browser testing and stuff like this, like using something like Agent Browser?
No. Like if I'm building some feature, like something like your deep research or scraping, and they switch a provider, they would test cost, speed, quality, using LLMs as a judge, without me even saying like test it after changing it. And that's didn't happen in the previous generation of models.
That's sick. We have seen that a little bit more. They got much better at like computer use and browser use, and they're much more likely to do it without being told, for sure. The whole like concept here is like back pressure, right? Is like, how can you take what you built and give the model like deterministic, like, LLM as a judge is fine, and LLMs can review code and they can review outputs. But like, if you can actually say like, hey, here's a number, like the conversion on my website that is directly tied to the success of my business, to how much revenue I'm getting, to how many users I'm converting. That is crazy powerful.
I was about to say that's the same idea behind like the slash goal. If you can tell it a measurable output, the agent will move mountains for you.
That was the same thing as auto research, right? Is like, just go make this CUDA kernel faster until it like, whatever it is you've reached the 20% resource reduction or whatever it is, right?
Yep.
And so like, some of the things we like to do here is like basically actually pull up a doc that we did. Yeah, so here's like a PRD I made in HumanLayer that is like, here's how you bring your custom workflows into Riptide. So it's like here's the problem to solve, here's how we measure success. And I actually did this Amazon thing, which is like, write the blog post before you build the feature. Think about how you're going to explain it to users and why it's valuable before we ever write a line of code. So we're building this new JSON format, and then it comes with a bunch of like, we do HTML mockups to understand how, like, what it's going to look like. I did a bunch of iterations on this, and then like basically all of the different views in the app that are relevant, we kind of just like prototype them out with like plain HTML, and it seems to work really well. But this is like the product part. There's no tech here. There's no architecture. We're not talking about databases or schemas or anything. It's just like, what does the user see? What is the user's facing stuff?
Yes, having perfect clarity about like what do you actually want to build and why do you want to build it before getting into any prompting or coding.
Yeah, and like people,
I think that's important. You need to know what you want to make. So what's the ultimate goal? So a lot of that definitely will help moving forward. So before you do any type of prompting or using the model, you understand what it is you're looking to do. That is important.
people say like, oh, but this is just extra work and like the models are good enough now. And it's like, sometimes, right? You can roll the dice and just see what comes out. But if you spend 20 minutes going back and forth and figuring out what this looks like, you can do a lot. You can like raise the chance that whatever the agent ships does not need a bunch of like hand polish or tweaks, or you got to like vibe a bunch of changes to the UI or whatever it is.
Yeah, the models are also good enough at like doing what you tell them and never calling you out about like, yo, you've been working on this for days and there is zero progress and like you still have zero users. So like, you know, that's the dangerous part.
So, I mean, you mentioned like understanding the product part. That's one example. The next thing we do is like system architecture, right? If you want to save time during review, you pick whoever would review the PR. I mean, if you're solo, then this is a different story, but it's like whoever would review the PR, especially if you're working on a team. We focus a lot on like, we work with publicly traded companies, a lot of like Series B plus fintech companies, people where you can't just like vibe it and hope it works, right? And like, oh, if it's broken, like we'll just fix it tomorrow. Cause it's like in those industries, if it's broken, you might get fined $1 million if you do something wrong. And so they are reviewing the code and stuff. And so we can do this high level architecture thing, right? Of like, hey, here's how the services are going to fit together, and here's the flow. Here's the new endpoints we're going to make. Here's the new tables, and then like outlines of the queries we're going to do. And this is like going down one more level, right? This is what a lot of people do. A lot of people have gotten to the point where they're quite comfortable working back and forth with models to design the system architecture. And this is really good. Do you do stuff like this?
I'm not at that level. So, you know, right now I'm launching a new startup. So with like 2 developers. So I'm not there yet.
So yeah, the other like asterisk on this, right, is like there are times to vibe code. This is like less about vibe coding than anything else. Like if you are a pre-product market fit startup and you have to figure out what's worth building, and you just have to like put as much different things in front of customers and figure out what they're willing to pay for, like this is probably overkill. But if you're on any kind of team, even like around like 5+ engineers, where it's like, okay, we know what we're building and we have people paying for it, and we need to make sure that it like is going to be around in 6 months and that we're going to be able to maintain it. This is kind of step one. The thing that I think most people skip is actually what I call like program design, is like actually going before you let the agent go cook. There are decisions that it's going to make that you might not like. We see a lot of people actually going one layer down of like, here's actually what the call stack of the program is going to look like. Actually, Dylan Mulroy from Cloudflare did a tweet about this recently that's really good, which is like most of his plans actually end with like, here's what the tests are going to look like, and here's what the call stack is going to look like when we go build this. And again, the most important thing we talk about is like, I use the word leverage a lot. How can you spend a little bit of time up front to increase the odds that the thing that comes out is not going to need a lot of fixes and changes before you can merge it? Or after you merge it, you're going to have to go back and clean it up, right?
This is basically like the inverse process. I don't know if you've seen the tweet by Victor Tallinn, but basically it's like when the models do a change, ask them, while working on this, which choices did you make that you're not confident of?
Yeah, I've seen this, yeah.
Yeah, so that's basically doing this before the model runs.
Exactly, yeah. My take is basically like once the model has written thousands of lines of code or even hundreds of lines of code, it is harder to change then because you're deep in a context window. You've done, even if you use a lot of subagents, like there's a lot of context there and you're already kind of biased in one direction by what the model chose in the first place. The sessions that generate these kind of docs are very context light. Like the model has all the understanding, but it's doing it in a very token efficient way. I have one of these in progress. Let me go pull it up. This is like the conversation back and forth. We're at 43,000 tokens, and we've already made a lot of decisions. We read the PRD in this session, and then we've already made a lot of decisions on like how this is going to fit together, what the endpoint's going to look like what's the flow, what's the actual like. So this is our program design. Actually, this is just the architecture still.
So I like that point that he made about leverage. So you're looking to find ways to get leverage so that whatever you're doing in the end is as clear, clean as possible. So you do a lot of front end work to get a lot more clean and clear back end work. Love to hear what you think. If you want to hear more, make sure you like and subscribe.